Hello, dear students. Today we are going to see the concept of equivalence classes. So, if R is a equivalence relation on the set A, and if small a is an element of the set A, then the equivalence class of the element A is nothing but the set of all elements from the set which are related to the element A through the relation R. So here the equivalence class of the element A is denoted likewise using square brackets, and the mathematical definition of the same is given here. So now we are going to see the same with the help of an example. So let R be the following equivalence relation on the set A. So here the very important thing is that in order to find equivalence classes, the relation needs to be an equivalence relation. So here we have already been given that the relation R is equivalence. So firstly, I will write down all the elements of the set A and try to find their equivalence classes. So I can find equivalence class for all elements of the set A. So 1, 2, 3, 4, 5, and 6. So now what I'll do to find equivalence class of 1, I will refer the relation R and see which elements are related to 1. So 1 should be the first element in the tuple, and whichever second elements are there in that tuple, those will come in the equivalence class. So here in this case, I have 1 as the first element. So the second elements 1 and 5 are those which are related to 1 in the relation R. So they'll come in the equivalence class. Same for 2. The tuples to be considered for 2 are this, this, this. So the elements that are related to 2 in the relation R are 2, 3, and 6. Similarly for 3, it is 2, 3, 6. 4, it is just 4. For 5, it is again 1 and 5. And finally for 6, it is 2, 3, 6. So in this way, you can find equivalence class of all the elements in the given set. So here, there are certain properties of equivalence classes. The first is that any two equivalence classes are either completely disjoint or they are the same. So we can verify it with the previous example. If you see take any two equivalence classes, let's say 1 and 2. They're completely different. Why? Because there is no common element in both of them. Whereas if I consider 1 and 5, they're entirely same. Why? Because both of them are 1, 5. Similarly, you can consider 3 and 6. They are same. 6 and 2, they are same. 4 and 6, they are not the same. Okay, so you can verify this property yourself. Second is that for any x which is an element of the base set, x will be an element in its equivalence class. And third is the union of the equivalence classes of all elements is the base set itself. So you can verify these properties on your own considering the previous example.